Okay, I've looked around. Half of you are sort of getting there. Some of you are very confused with your equation for D. Let's give this a go, shall we? I tried to make it as obvious as possible. This is just a right-angled triangle, okay? So D comes from Pythagoras, yeah? So you're going to get this. D squared is equal to these two squared, yeah? Take the sum, okay? So you're getting 100 minus 30t, all squared, right? Plus 100 minus 40t, all squared, okay? Now, after you simplify that out, let me just double check the number that I got. You're going to get a quadratic, yeah? Yeah. Under root. Yes, when you take the square root. Because you got huge numbers, I'm going to take out a factor of 100. And I think what you're left with is still something quite large. 25t squared minus 140t plus 200. Check out?
Yeah.
Yep. Good. Hope so.
Yes.
Now, that's an equation for d squared. Not a whole lot of use if you want to differentiate it though, right? So you take the square root. Don't miss this part. You're just dealing with algebra here, right? So even though you know it's a distance, you can't just go to the positive value straight away. You guys know this, okay? If you're going to disregard something, you've got to provide the reason. So, slap your plus or minus on the front. I've put the 100 out the front because it's square. Good. And the rest of it comes underneath the square root. Okay. Now, like I said, you want to disregard one of the values. Do remember to say why d is greater than 0. It's a length. Okay. Now we can go from here. Okay. This, when I've got a positive value, is something I can differentiate whenever Justin's ready.
Yeah, is this minus 140t in d squared?
I think so.
Minus 1.4. Actually, that might be right.
I'll keep going. Now, it's that to the power of a half. There's not really many shortcuts you can take here. You're going to use chain rule, yeah? So I'm just going to make that a little more obvious to the power of half, okay? And by the way, this is one of the reasons why it's worthwhile not to just write y dash or d dash and that kind of thing. We're differentiating with respect to a specific variable. So say what you're differentiating with respect to. D, capital D on dt, okay? All right, you tell me what to write. Simple chain rule. What do I start with? 10. 10's out the front. Now what?
Times half.
Okay, I've brought the power, hold on, minus a half? Times a half.
Yeah.
Brought the power down at the front, okay? Then this stays the same. But
Bring the power
power goes down by 1. Okay, now what?
times the inside.
Okay, I've just done the outside, so now I've got to do the inside. 25t squared is going to become 50t. 140t will become 1/4. Okay, so far so good? Yeah, okay. All right, now, before we go any further, okay, I could do some work here to simplify it, but what am I after? I'm just after turning points, right? Now remember that this part in here, because it's got a negative index, right, it's going to go on the denominator. So I almost don't need to worry about it, right? Because what I'm going to really be after for a turning point is the numerator being equal to 0, okay? That's going to give me a stationary point and I'm going to have to test it, okay? So let's just tidy this up a little bit. Okay, the square root 25t squared minus 140t plus 200 on the bottom. It looks gross, but don't get intimidated by it. Okay. What do I have on the top? 250 outside of? What was it? 5t minus?
That doesn't 24. It doesn't go in
No, hold on a second. I got 5 here, and you've taken out a factor of 10, right? Should be 250. This should be 5t minus 14. Does that look happy? Yeah? Okay. Now, just because we're running out a bit of a room, I'm not going to write the whole thing, but you guys know what to do now. Potential turning points, okay? I'm not interested in stationary points. Yeah?
Is that 15 times 14? Is that you?
What are you looking at?
50 times negative 14. What is that supposed to give?
I've just gotten a 5 from here, 5 from there, and a 10 from there. Pulled it out, there's my 50. Is that okay? Yeah? I'm actually not interested in, I could get out the number, but I just want this part here. That's what I'm going to use to solve it in a second, okay? So I'll say potential turning points occur when this derivative is equal to 0, okay? i.e. when t is equal to, alright, what is it? I think it's 1405, which is 2.8, I think. Okay, now, this is an obvious one, right? I have to test it to show that it's actually a turning point, so what shall I use to test? First or second?
Second.
What a jerk! Okay, I'm going to use first derivative. What a troll. I'm not differentiating again.
So we were just off by 2 orders of magnitude.
Oh, that's pretty close, Jesse. That's great.
Not bad.
You'll be a wonderful engineer one day. So take your value for t.
Because it'll take you forever.
Okay.
It'll take you forever.
It's a quotient, so I want to avoid it, right? So 2.8, ideally, I think here, we want to go 2.7, 2.9. Okay? Okay, now, you'll get some numbers in here, right? I'm not particularly interested in what they are right now. I'm interested in the method, but just please actually get a number in these places, okay? Once you get them. Therefore, you are going to indeed show that this is a minimum. Okay, that's kind of nice, right? And that's what we were after, right? So the time is 2.8 hours. And if the question asked, you could work out, okay, what is the actual distance between them? I think it works out to be 20 kilometers at that point, okay? Now, why did I draw this question out? Apart from the previous one, which is a really gross similarity one, the thing about this is that you have to be so careful in what you assign as your actual variables. It's all in the setup. The rest of this, it's all just mechanical, okay? But if you get this part wrong, if you just call this y, and you just call it x, you just go round and round in circles, or triangles, okay? So be careful, be thoughtful.
In the textbook, I think they